to part 6, I believe, or 7 for week 6. A lot of different parts here, and we're going to talk about string streams and how we can use them in C++. So, what is a string stream? I'm going to stutter so many times saying string stream. Using string streams. So, a string stream basically allows us to write or read from a string in memory. So if you think about it as if we had like a file that was in memory, so it's not actually saved anywhere. Just as we would write and read to files, we can read and write to strings that are stored in the memory or the RAM of our computer. It's very powerful and it's very useful for things like data validation, which I'll show you an example of at the end of this. So a string stream uses the class string stream, I string stream, or O string stream, obviously for input or output, or just for both. And we have to include the stream preprocessor directive when we want to use string streams in our C++ project. So step 1 is including that preprocessor directive, then declaring the string stream object. Then we connect it to the string that we want to actually read or input or output from. So we can copy it, or we can, you'll see in the C++, when we actually set the string, you can set it to a string that you already have declared, or you can set it to a string that you want to output from or to. And then we read and write the data from or to that string stream using our formatted IO input output. So what does that actually look like? So we include string stream at the top of our main.cpp. Then we can create a couple variables here, num, total, which is a double, our string name, and then we've got our string info, which has mo 100 and 1234.5. Okay, so info has all of the stuff that we want to put into num, total, and name. All right. So imagine if info was a file that we were reading from. It's the same process how we do it, except now we're using string streams and it's in memory. Okay. So now we create our I string stream object, which is our input, as if it was an input file, and we create it called ISS. We just created it, it stands for input string stream. And then we base it off of the string or the file that you want to, read from. And we want to read from our info string since that has all of the information. Then we can output using the insertion operators, the name, num, and total in the order that they're shown in the info string, and they will then be put into those variables. We can also write to a string stream using the string stream preprocessor directive again. This time, we've got num, total, and name that are declared and initialized with values 100, 1234.5, and mo. And then we create an output string stream, or imagine writing to a file, and you're creating a file. Okay, it's the same as an output file. Now we do OSS, and it's initialized to an empty string stream. And then we're going to output the name, a space, the num, a space, and the total, which is coming from those three variables. And then if we do oss.str and print that to the screen, we'll see when we print oss.str, or we read from that string stream, or imagine if it was a file that we outputted those variables to, it would then contain those variables. Okay, so it's very, very powerful, and they're all stored in memory. So there's no, actually saving a file to your system. It's all done in memory, and then when the program's over, it's all cleared. So we can use that to validate input with string streams in memory, and it's very, very useful to do it this way. So we've got a value that we're taking, and it's type integer, and we've got input from the user stored in a string. We're asking them to enter an integer, okay? And then we're going to store what they enter in input. But you'll notice input is actually a string. Even though we're asking them to enter an integer, it's stored in a string, okay? A little bit confusing, just bear with me as we go through this example, okay? So their input will be stored as a string, even though we're asking for an integer. Then we create a string stream object, and we're going to base it off of the input string that the user created, all right? Now we're saying if the string stream can be put into the value variable, which is of type integer, okay? So if we can use that insertion operator from our string and put it into an int object or an int variable, not an object, sorry, a variable of type int, then we'll say an integer was entered, because obviously that won't work if it's not an integer, okay? else an integer was not entered. So we can check if people are entering integers or not integers. If you think about it, when a user enters the numbers 1, 2, 3 from their keyboard, okay, like this actually a string because they've entered 1, 2, 3. Then what's going to happen is this 1, 2, 3 is going to be stored in that buffer or that string stream like this with that end character at the end. And then it's going to put it into this int variable down here. And it's going to be then converted to an actual int. And then obviously, if it is converted and that is successful, then we're going to say an integer was entered. Obviously, if it doesn't work and say they entered the number or the string, and they typed 1 like this, that's a string and that's letters. And 1 will not get converted with the insertion operator into an int, right? That won't work. So then basically this else will fire. Okay, so we can use that for data validation. Here's the example of what the code looks like. We'll jump over to CodeLite and I'll show you guys how that works. So coming down to the end here, I've got my data validation example. I'll uncomment this out and you can download this from Blackboard. Before I get into that, actually, let's show you guys some string streams using input and output with basic string stream stuff. So make sure you have limits, string stream, and iomanip in your preprocessor directives at the top here, these three. Okay, so I just commented them out there just so I remembered to remind you guys that we need those. And then let's do this. Okay, so we've got the same examples that I covered in the PowerPoint, but I'm just going to show you in CodeLite. It might help. So we've got our 3 variables we're declaring, an int, a double, and a string, and they're named num, total, and name. They're all empty. And then we've got one string here called info, and it's got 3 things in it, separated by space. And one is a string, one is an int, and one is a double. Okay, these are all initialized to nothing. Okay, now we create an input string stream object and call it ISS. And then we initialize it to the info string. Okay, that's very important. It's not empty, it's actually initialized to this string. And then when we use the extraction operator from our ISS string stream in memory, it's going to now extract mo into the name string. It's going to extract 100 into the num int, and it's going to extract 1, 2, 3, 4.5 into the total double. Then when we see out, I'm just using the setW function, giving it 10 wide, aligning it left, setW to 5 on my num, and then setW 10 on my total. So let's run this. I didn't set it to my active project. Let me just exit that. So run this project and see what happens. Obviously, I've still got some stuff that's not commented out up top here, so I'll just do that. Okay, sorry. So we run this, and like we expect, we get mo with a column wide of 10. Then we get 100, which is our number, because we output our number. And then we get our total, which is our double. And it also has a column of 10. Cool. So we'll comment that out. Hopefully that helps. And then we'll look at an output example. So very similar to outputting to a file, except this time we're outputting to a string stream in memory. So we create an O string stream object called OSS, and it's initialized to nothing. It's empty. And then we have these 3 variables again. Where are they coming from? Oh, I guess technically I should leave this uncommented. So these 3 variables will have values in them because those values have been put into them from the input string stream. Okay, so the the num, total, and the name variables will be set to mo, 100, and 1234.5. Now, when I have my OSS, O string stream object that's initialized to nothing, when I output from it or I read from it, I'm going to write, sorry, I'm not going to read. This one is reading from it. I'm going to write the value of left, the value of num, the value of total. Now this might make a bit more sense if I actually comment these out, copy these, comment these out, go like this. Let's set our number to 100. Set our total to 1234.5. Let's set our name to Ben. Okay. So I'm going to write these values that have been initialized in these variables to the OSS object. And then I'm writing them with set width of 10, set width of 5, and set width of 10. And then what I'm doing is I'm actually going to print to the console oss.str. The str method will actually just read the full string from my OSS or my output string stream object in memory. So it should print these back to me. So just like I expected, there's Ben 100 and 1, 2, 3, 4. It's printing back name, num, and total. Okay. Very cool. Comment these out. The last example here is the data validation, which I covered very quickly in the PowerPoint. So here we've got a couple values. Bool done equals false. That's just for our do loop. So while we're not done, it will do all of this. And then we've got a couple variables. One's called value and one's called entry. And they're both initialized to nothing. We're asking the user to enter an integer, and then we're going to store what they enter in a string, which is very confusing, maybe at first, and you'll see what happens a little bit later, and I'll explain it again. So we've got our input string stream, and we've called it validator, okay? And we're setting it to the string of what the user just entered. And even if the user entered the numbers, like I said, 1, 2, 3, that is still a string, okay? So our validator input string stream, you can imagine it as it's a file or something, as if it were a file, has this string of 123 in it, okay? Now, if the validator can extract the value and set it to an int, which is of named value, obviously, and it's type int, if it can extract that string, 1, 2, 3, and put it into the value variable, then we will set done equal to true, and then it will exit the loop. Otherwise, it'll keep repeating, sorry, that's not an integer. Sorry, that's not an integer. And then you'll see this little line of code, which may be a bit confusing. Whoops, at first. This line of code will discard everything in the input buffer to the next new line. So if I enter, let's say, for example, if I enter a 1, 2, 3, and it's a string, right? When you enter it off your keyboard, it's automatically string. And then I enter the words hello, okay? It'll read this. It'll put validator into value because it says, yes, this is a number. But then this, everything here, will still be in my buffer, okay? Everything in here is just sitting there. Remember, we've got our buffer, right? When we're reading from the keyboard, and it's read this and it said, yes, we've got our number. Okay, that works. But then we still have hello sitting in our buffer. So maybe next time we ask for something or a string, it's going to pass us hello. So what this does is this discards anything in the input buffer. So it'll do cin.ignore, which I talked about before in the past. And then we use our numeric limits, which is basically why we include our limits preprocessor directive at the top here, this limits class. And it's going to go to the very, very end of our buffer. So everyone's buffer size is different depending on your computer. That's why we need our limits. So it goes to the very end of your buffer for your string stream. Because string streams are stored in memory, they all have different sizes. So because I have more RAM on my system, I might have bigger capability or capacity for a string stream object stored in memory than your computer. If you had a really old laptop, you might have a smaller memory allocation for your string streams. So that's why we're using our limits class to go to the very end and get the max, the very furthest blank space character or new line character, and we're going to ignore all of it. So we're going to discard all of that garbage that's entered after a number. And then basically, that's basically what happens if they don't enter a number. Okay, so it just discards the input buffer. Actually, that's outside of this else. So this happens no matter what in each iteration of the loop. So I just had to correct myself there. Then we just see out, you entered the integer, and we print the value. Because we know if we've exited the loop, we know that done was set to true, which means this is a number, and we know it's an int, so we can be pretty confident with our validation that we've got an integer. So let's take a look at this. Let's run it. What does this look like when we run it? Okay, please enter an integer. So like I said, if I enter a string, it's going to try to convert that string into the int value, and it won't work. So basically, this if statement will fail and it will print, sorry, that's not an integer. And that's exactly what we see. Now, if I enter 123, that's a string because I typed it with my keyboard, but it will convert it into an int because those numbers can actually be put into an int. And then it says you entered the integer. Obviously, we exited the loop because done was set to true. You entered the integer 123. Now, if I run this again, here's another interesting use case or edge case, I guess you could call it. If I entered a float, 12.34, what would happen if I didn't have this line of cin.ignore on 150 over here, okay, that ignores all of the garbage, is it would read the first two numbers before the decimal as an int, okay, as 12. And then it's gonna look at this as 0.34, and it would store that in the buffer as the next item in the buffer. That's why we have to do cin.ignore, because then basically it ignores everything else in the buffer. And this could stretch on forever, and it's just going to ignore all of it. And it's just going to flush our buffer, refresh it, and set it to empty. Okay, because if we enter 12.34, check this out. If I exit this, it's going to say you entered 12. Oops. You entered the integer 12, and it discards the 0.34. Obviously, because 12.34 is a float, and it cannot be converted into a value of type int. 12 can be, so it takes that, and then it discards the 0.34. Okay. What if you entered 123 with a quote around it? That's a great question. Let's try it. Let's see what happens. So you're saying if I did this, I think it might see this first character symbol and know that it's going to try one character at a time, right? Like with the example of 12.34, it's going to try those first two characters, and those first two characters do convert to be an int. But because the first character here is actually not able to be converted to an int, I think it'll fail right away. That's just my guess. Sorry, that's not an integer, right? Because it's looking at the quote character symbol, and it's going to convert it to an ASCII value or something, and it's going to be like, yeah, that's ASCII value 79, which is not. That's my not my best. That's not an integer, right? Whereas when it converts, the string of 1 or 2, and it converts it to the ASCII value of, I have no idea, I'm just making these up, of 200 in ASCII, it's going to say like, yep, check, that is, and it will convert it. Hopefully that makes sense, Simon. So I could do this. I could do 234, Benjamin is the best teacher ever. And look, you entered the integer 234, and it just discards all of that and flushes the buffer. Right? So hopefully that makes sense to you. That's how we can do data validation, and we can make sure that we get ints. You could do this with a different type. You could do it with strings. You could do it with floats to make sure that you get the right data type that you're looking for. Okay, and I'm sure you guys can figure some of that out on your own. Cool. So that is using string streams. Is there any other questions about string streams? All of this code that I've covered today is in the week 6 IO streams and files on Blackboard, which you can find right in the week 6 weekly learning folder. In the next video, I'm going to introduce the exercise 3, which is the lab for week 6. So you guys will be marked on it, and there will be submission for it. So I'll cover that in the next video. I'm going to end this recording here. So thanks for watching this part, and I'll see you guys in the next section.